got the magic in me. Every time I touch that track, it turns into gold. Everybody knows I got the magic in me.
What a magic trick. Wow. So, again, Mr. Durkis, Tech Boston Academy. Last video, we learned about real numbers. Today, we're going to add and subtract them. This might be review for some of you. It might be new for some others. But you need to get this down. It's going to carry you through the whole year. So this first one we have 3 plus 5. This is a nice, easy, basic one to start off with. 3 plus 5, well, that equals 8. Now they get a little bit more complicated. We have negative 3 plus minus 5. So we have two negatives. What I always do, not always, I do it sometimes. I put a grouping symbol around this negative 5 just to show that it's different. What I also do, if you have a plus and then a minus next to each other, you don't need that, right? In higher level math books, when you get higher in high school, there's just going to be one symbol. So if you have a plus and a minus, it becomes a minus. All right, so I forgot that 3. Negative 3 minus 5. And the way I think about subtracting negative numbers is when people owe you money. So if somebody owes you $3 and then another person owes you $5, well, in total, people are going to owe you $8. So when you subtract a negative from a negative, it gets more negative. When we're in high school now, you have access to calculators all the time. We have number lines. So I want you to get the right answer. So feel free to use a calculator whenever you need. Next one over here, same deal. We've got a plus and a minus. So I can put grouping symbols around that, but I really know this is going to be a negative. So this is 3 minus 5. Stick it in a calculator, look at a number line. This answer is going to be negative 2. Lastly, we've got negative 3 plus 5. This is different because we have a negative first and then an addition. So if I do a number line just to show you how it works, we've got 0, negative 1, negative 2, negative 3. I promise that's negative 3. Plus 5, we're going 5 to the right. 1, 2, 3, 4, 5. And this spot right here, 1, that's going to be 2. So this answer is 2. So now we have some rational numbers. It's the same rules as integers, but we just have to know how to add these fractions. That's where it gets a little bit complicated. Let's start with a decimal. We have 7.4 plus negative 9.5. Right, you have a plus then the minus. You can change this to 7.4 minus 9.5. Again, we have calculators everywhere, so we can just stick this in a calculator. So let me go to my calculator. Oop, wrong page. So what we're going to do is just type it into the calculator. 7.4 minus 9.5. That equals negative 2.1. You can also use parentheses in the calculator too. So let me just show you how that looks. 7.4 minus parentheses. Oh, sorry, it wasn't minus. Let me back that up. Plus parentheses negative 9.5. Same answer, negative 2.1. That's negative 2.1. You can also, add them vertically. 7.4 minus 9.5. Make sure the decimals are lined up, and then you subtract them. All right, over here we've got two fractions. The denominators are the same. We have a common denominator, so all you have to do is add the numerators, the top numbers. So I know my answer is going to have a 5 on the denominator because these are both 5. So now the top, that's going to be negative 2 plus 4. All right, put that in a calculator, use a number line, and that's going to be 2. So your answer is 2/5. Over here, these ones don't have a common denominator, so we need one. What you can do is think of a number that I can multiply these by, and they'll both equal the same thing. If the numbers are small, you normally just multiply them by each other. So I want to multiply this 8 times 3, and I need to multiply the top by 3 as well. So 3 times 3 is 9. 3 times 8 is 24. There's a negative sign, so I put that back over here. And if I want 3 to equal 24, I need to multiply it times 8. So times 8 on top and the bottom. That's a multiply sign. 2 times 8, that's going to be 16. 3 times 8 is 24. We have a plus and a minus. Is going to stay minus. So the bottom, the denominator, will remain 24, and the top, negative 9 minus 16, that's negative 25. And I just want to show you one thing about this answer. You might see it written different ways. We just wrote negative 25 over 24. That is the same as 25 over 24. I mean, negative 24. So you could put the negative on the numerator, the negative on the denominator, or sometimes you see the negative written outside the fraction, like that. But these are all the same thing. Over here, we have a couple more complex ones, but you just follow the same basic steps and we can get the right answer. We start off with a mixed number over here, that we have a number on the outside and then a fraction. We want to change this to an improper fraction before we add it. So to do that, we multiply 4 times 3, and then we add the 3 on the top. So 4 times 3 is 12, plus 3 is 15, and we keep the same denominator. And then we need to change the 4, so we'll have the same denominator. This is really 4 over 1. That's a trick to changing a regular number, a whole number, into a fraction that you need. So how can I change a 1 to a 4? Well, I need to multiply that times 4. So if I multiply the top and the bottom times 4, 1 times 4 is 4, 4 times 4 is 16. Now I can add them. The denominators are the same. So the bottom is 4. 15 plus 16 is 31. And let me write that a little clearer. 31 over 4. And there you go. Over here we've got absolute value, and I want you to remember GEMDAS. The G is for grouping symbol. Absolute value bars, that is a grouping symbol, so you need to do what's on the inside first. I see here I have a plus and a minus. I can change that to a minus. So 3 minus 11. 3 minus 11, that's going to be negative 8. And these are all in the absolute value bar, so the absolute value of negative 8 is 8. Over here, I want to use the same order of operations. This is called a radical. That's the same as a square root. It's a grouping symbol, so we have to do what's inside the radical first. Negative 5 plus 30, that's 25. The square root of 25, that equals 5. Alright, what I want you to do now is pause this video and try these ones. Try them, right? So pause the video, give them a shot. Alright, let's see how you did. So this one over here, negative 2.3 plus negative 14.8, you can change that to negative 2.3 minus 14.8, and I will stick that right in your calculator. This one over here, we have 5 over 4 plus 5 over 6. We need a common denominator, so I multiplied this 4 by this 6, and I did the 6 times 5, and that became 30 over 24. And I changed the denominator of this one to 24 by multiplying 6 times 4 and 5 times 4. That gave me the answer of 50 divided by 24. We can simplify that. These are both even numbers, so you can divide by 2. So if you divide 50 by 2, that equals 25. If you divide 24 by 2, that equals 12. So that is a simplified answer right here. This one over here, we have absolute value and we have some fractions. I want a common denominator, so I multiplied the 7 times 3, the 4 times 3, and I got 12, negative 12 over 21. The 1/3 I multiplied by 7 over 7, and I got 7 over 21. When I subtracted negative 12 from 7, I got negative 5. The denominator of 21 stayed the same. And the absolute value of negative 5 over 21 equals positive 5 over 21. All right, let's talk some properties. So the first property we have is the commutative property of addition. If you Google it, this is what you get. A plus B equals B plus A. This is a beautiful, beautiful property. It just says that you can move these letters around and you get the same thing. This might make sense if I put some numbers in there. So if A equals 4 and B equals 1, this is saying that 4 plus 1 is the same as 1 plus 4. Right? These both equal 5, so it just tells you can move around the numbers if you're in an addition problem. Sometimes if you do a problem and the answer says x plus 2, but you got 2 plus x, you might wonder, did I get the right answer? Well, you did, because the commutative property says that you can move around the numbers. I like to remember this one by thinking of the word commutative. That has the word commute in it, and that means move, right? So you can move around. And here is a picture of me in a car commuting, right? So commuting, moving around, you can move these numbers around. The next property we have is the associative property of addition. This says that you can put addition problems in groups and you'll still get the same number. So this one they grouped A and B, this one they grouped B and C, and we should get the same answer. They should be equal. So if I put it in context, if A equals 1 and B equals 2 and C equals 3, that's a 3. That should be the same as 1 plus parentheses 2 plus 3. Well, let's find out. You need to do the parentheses first. 1 plus 2 is 3. And I have 3 plus 3. And that equals 6. Over here, I have to do the parentheses first. 2 plus 3 is 5. And I have 1 plus 5. And that equals 6. So these are all equal to each other. And the way I like to think about the associative property is about who you associate with. What group do you belong to? Who is your clique? Right? So this is my clique. Nobody's messing with them. This is the group that I associate with. So the associative property talks about you can group different numbers in an addition problem and you'll get the same answer. All right, let's do some subtraction. So these will be similar to what you saw in the addition ones. So let's get to work. 3 minus 5, and that's going to be negative 2. Again, use your calculator, use a number line, use whatever you can. 3 minus negative 5. When you see these two negative signs together, we just want one sign. This becomes a big old plus sign. 2 negatives in a row means a plus. 3 plus 5, that's 8. Over here, negative 3 minus 5, right? Think about it. If someone owes you $3 and they owe you 5 more, altogether, they will owe you 8. This one over here, I believe, is different than what is written in your packet. So you can just cross that one out and write this down. And again, right, we have a negative and a negative. That's going to become a plus. So 3 plus 5, negative 3 plus 5, I mean. And that's going to be 2. All right, what I want you to do now is pause this video and try these on your own. All right, we've done some examples of adding them. You should be able to try to do this right now. All right, this first one, you should have put this in your calculator, or you can line them up if you want. When you have a negative minus a negative, that becomes plus. So this would be 12.4 plus 3.5. and you should have gotten 15.9. Over here, the denominators are the same, 9 and 9, so I can just subtract negative 2 minus 4. That gave me negative 6 over 9. This can be reduced because 6 and 9 can both be divided by 3, and that gives me negative 2/3. This one over here, a little bit more complicated. 5 and 3, those are the denominators. I want to make them the same, so I multiply 3 times 5, and that gave me 15. I multiply 5 times 3, that gave me 15. And I had to do the same for the numerator. So 3 times 3 is 9. It was negative, so negative 9. 2 times 5 is 10. This was negative, negative, so it became plus. Negative 9 plus 10 is 1. 15, 15. You keep it the same, so 1 over 15. This one over here, we had a mixed number. I changed it to an improper fraction. I did 4 times 2 is 8, plus 3 is 11, and that's over 4. And then this minus 4, that's the same as 4 over 1. I multiplied it by 4 over 4. That gave me 16 over 4. 4 and 4, the denominator, it stays the same. 11 minus 16, that gives you negative 5. This one over here, remember my old friend PEMDAS. So the absolute value bars are a grouping symbol, so I need to do what's inside first. We have a negative and a negative, that became a plus. So 3 plus 14 is 17. The absolute value of 17 is 17. A mistake that I always see, if the value inside the absolute value bars is positive, people make it negative, but it's always going to be positive. Over here, again, PEMDAS, we have a radical, a square root symbol. So we need to do everything inside first. 39 minus 30 is 9. The square root of 9 is 3. If you remember the square root, that means what number multiplied by itself equals 9? Well, 3 times 3 equals 9. Perfect. Let's move on. So, do the commutative and associative properties, are they true for subtraction? Let's find out. So the commutative property, that said that A plus B equals B plus A. What if we did subtraction? Is A minus B, is that the same as B minus A? Well, let's put some numbers in to check it out. What if I did 8 minus 3? Is that the same as 3 minus 8? Well, 8 minus 3, that is 5. 3 minus 8, that is a negative 5. So these are not equal. So this is no, not true for subtraction. Bad. What about the associative property? Remember, this is who you associate with. This is the groups. So I believe it was A plus B plus C, and I put grouping symbols there, plus A plus B plus C, and I moved the grouping symbols over there. So that's addition, but does it work with subtraction? A minus B minus C with the grouping symbols like that, or A minus B minus C. So let's put in some numbers, because I can't really make sense of this without them. So if I said A was 8 minus 3 minus 2, is that the same if I group them like this? 8 minus 3 minus 2. Well, 3 minus 2, that's 1. So I have 8 minus 1, and that's 7. Okay. 8 minus 3, that is 5 minus 2. 5 minus 2 is 3. So no, these are not equal. This is not true either. No, 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 no. You might be thinking to yourself right now, Mr. Durkis, in the last video, you talked about irrational numbers. What haven't we learned about them now? Well, we're going to do it right now. I got you. Don't worry about it. So, I'm going to show you when you add a rational and a rational, what will your answer be? A rational and an irrational, and two irrational numbers. What do you get? So the first one, these are two rational numbers. If I wanted to add them together, I need to change the denominators to make them common. So I can multiply 2 by 5 over 5. That's really 2 over 1. And that becomes 10 over 5 plus 4 over 5, and that's going to be 14 over 5. So this is a rational number. So whenever you add two rational numbers together, your answer will be irrational. Over here, we have a rational plus an irrational. 2 is the rational, square root of 3 is the irrational number. All I can really do is put it in a calculator and see what I get. So if I do 2 plus the square root of 3, this number, it does not repeat, so it is a irrational number. So no matter what you do, if you do a rational plus an irrational, your answer will be irrational. Over here, if I have square root of 7 plus the square root of 2, these are both irrational numbers. If I put that in a calculator, square root of 7, close the parenthesis, plus the square root of 2, another irrational number. The number, it does not repeat itself, it does not end, so that's irrational. But there is a special case when, like if I take this number over here, this by itself is an irrational number. So if I said 2 plus the square root of 3, and if I add it to negative square root 3, so this is irrational, that's irrational. If I add these together, this square root of 3 and the negative one will cancel, and my answer will be 2. So this could really be either. Okay, perfect. So I started off this video with a magic trick. I'm going to end you with one of my favorite magicians doing some magic. So enjoy this. Darkus out.